Okay, so hello everyone. I feel this Chinese remainder problem is a little hard for you to understand. So I will use a general method to teach you how to solve this kind of question instead of listing. Okay, so firstly, we know it's all things about the remainder problem. So the remainder problem, of course, the remainder problem, we need to focus on the remainder. So the main result is I need to find out what? I need to find out the dividend. Okay, dividend. Okay, so now let's think about the basic things is I need to find out one divisor equation. So I will use the congruent equation to solve that. So we have a new thing about congruent equation. What's that? Okay, so maybe it's your first time to listen to this word. Okay, so I will introduce here. For example, I have one equation. 5 divided by 2 equals to 2 remainder 1. 7 divided by 2 equals to 3 remainder 1. So for here, I can see 5 divided by 2. We have remainder 1. 7. We also divide by 2. We have the same remainder. That means when 5 and 7 divided by 2, we have the same remainder. We have the same remainder. Okay, so that means we see they are congruent. 5 and 7 are congruent when mod 2. So I can see 5 is congruent to 7 if I mod 2. Mod 2 means divide by 2, okay? So, but this is about the congruent equation. So it should be like the equation, like the algebra equation. We should have the unknown letter. So we can see, for example, if I say x is same remainder as 7 if I mod 2. Okay, so because 7 I can separate into 2 plus 2 plus 1. 2 plus 2 plus 2 plus 1 if I mod 2. Remember what I say. The mod 2 means divide by 2. So 2 divided by 2, remainder 0. 2 divided by 2, remainder 0. 2 divided by 2, remainder 0. 1 divided by 2, the remainder is 1. So I can do the simplify into x is congruent to 1 if I mod 2. X is congruent to 1 if I mod 2. So now I have already find out x, the smallest number, is 1. If I divide by 2, the remainder is 1. So I can write into the general form. The general form, I will use 2k plus 1 to represent. So they are all about the odd number. So once the number I can write into 2k plus 1. That means what? That means I divide by 2. The remainder is always 1. So this is the general form, and k equals to 0, 1, 2, blah, 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 blah. Okay, so now about the congruent equation. So there are some very important things. The firstly is about the simplify. For example, if I say 3x congruent to 4 if I mod 10. So this time 3x can 4 of course cannot exactly divide by 3. So we cannot do it like that. But who can? So we can have a try. 3x is same remainder as 4 plus 0 plus 0, right? If I mod 10. So this means if I plus 0, actually I'm not only plus 0 because we plus the number divide by 10, the remainder is 0. So 0 divided by what? The remainder is 0. So who divide by 10, the remainder is 0? 10. 0 and who divide by 10, the remainder is 0? 10. So I can see 3x has the same remainder as 4 plus 10 plus 10 if I mod 10. So we can see 3x has the same remainder as 24 mod 10. So this time I can divide by 3. X congruent to 8 if I mod 10. Now, after that, I can get the equation is x equals to 10k plus 8. Here we see x equals to 10k plus 8 is the general form of x for this congruent equation. So why we need to focus on the congruent equation? Because this is a very, very important thing in the number theory. Okay, in the number theory. Actually, it's very useful. So before we use that, there is another very, very important thing about the congruent. So when I can divide by 3, for example, 2x congruent to 4 if I mod 6. So this means what? This maybe means x congruent to 2 if I mod 6. Because someone say, okay, teacher, I can just divide by 2 on both sides. Yes, you can. But let's see, if x remainder 2, so that means x equals to what? 2, 8, 14, 20, and blah, blah, blah. That means x equals to 6k plus 2. But let's look at this equation. If x equals to 5, that means 10 divided by 6, the remainder is also 4. But where is this 5? Is it in this sequence? No. That means this one is wrong. So which one is correct? Be careful. When we do the division, okay? 2x congruent to 4 if I mod 6. When we can do the division, only we have the co-prime, we can do the division. These 2, 4, and 6, of course, they are not co-prime. These three numbers are not co-prime. So that means I need to divide, when I divide by 2, this, the mod number should also divide by 2. That means x is congruent to 2 if I mod 3. Then the correct one is x equals to 3k plus 2. This is the correct general form. Okay, so it's a very important thing. So now let me show you how to use this one to solve some special method, to solve some special question. So remember, in our Explore 4, not all the question we can use this listing or something else. We can find the same remainder or something else to solve the question. In our Explore 4, we should use some better method. We cannot list. For example, let me introduce an example. Okay, so here is an example. If I tell you a congruent to 2 if I mod 4, a is congruent to 1 if I mod 5, a is congruent to 5 if I mod 7. So these are three things. If you want to list, yes, you can. I teach you how to list first. Firstly, we think about the first one. A can be what? 2, 6, 10, 14, and blah, 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 blah. This is equation 1. I meet the condition 1. So let's find out the number meet the condition 2. When I see 6, okay, 6 divided by 5, the remainder is 1. So that means a can equals to 6. And each time I plus the LCM of 4 and 5, it will become 26, 46, 66, and blah, 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 blah. So this means I meet the requirement of 1 and 2. Now let's think about if I want to meet the requirement of 3. That means I divide by 7, the remainder is 5. Which number is possible? Only this 26, right? 26 divided by 7, the remainder is 5. Okay, the remainder is 5. So that means the smallest number meet this requirement is 26. Then I can see a equals to 26 plus the LCM of 4, 5, and 7, which is 140k. So here is the general term. But now we cannot always do the listing method. It's not always possible because this one I only have 4, 5, and 7. So that means you have a list, it will be a little number. But yeah, if you want to calculate that, so for example, if I change the number, maybe mod 7, mod 29, mod 43, yeah, can you still list? It will waste a lot of time, right? So now let's introduce another method. This is method 1. Let me introduce another method, method 2. We call it satisfy 1 by 1. Okay, satisfy one by one. So we can see this part, yes. If I want to satisfy one by one, so firstly, let's focus on the first equation. A congruent to 2 if I mod 4. Then I can write down one very important thing. What is the general term of A? A equals to 4k plus 2. And then this is the general term which meet the requirement 1. Let's put into the second one, A congruent to 1 if I mod 5. So let's replace them. So we can replace this A by K. So it's 4k plus 2 congruent to 1 if I mod 5. If I mod 5. So that means what? That means I need to do the simplify. So of course, 4k plus 2, this one, I just 1, but cannot be minus 2. So I just plus 1, 5. The equation is still stable. So 4k congruent to 4 if I mod 5. So k congruent to 1 if I mod 5. So this time, can I just say k equals to 1? Yes, maybe k equals to 1, but this time we cannot just directly say k equals to 1 because this is means k meet the requirement of both 1 and 2. So we can write down like k, the general term of k is 5m plus 1. This m means I meet the requirement of condition 2. So now let's take the place to this equation 1. So a will continue become 4 times 5m plus 1 plus 2 equals to 20m plus 6. So that means this part 20m plus 6 means I meet the requirement of both 1 and 2. So now let's take the place of 20m plus 6 into the equation 3. A congruent to 5 if I mod 7. So that means 20m plus 6 congruent to 5 if I mod 7. So 20m I can separate into 14m plus 6m plus 6 congruent to 5 if I mod 7. So 40m, of course, it can exactly divide by 7. So we just cancel it. So the result will become 6m congruent to 5 plus 7 because then minus 6. So 6m congruent to 6 if I mod 7. So m congruent to 1 if I mod 7. So we can find the smallest number of m is equals to 1. Then take the place here. We can find a's minimum number is 20 times 1 plus 6 equals to 26. Then the general term is 26 plus 140k plus the LCM. These are two methods, and sometimes we should use the general method too, because I can solve all this kind of question. Okay, so now let's look at our example 4. So can we just use the congruent equation to solve that? Yes.